Dear students, myself Dr. Mallikarjun S. Biradar, Assistant Professor in Mathematics, Government First Grade College, Basavakalyan. So the 47th session of Graph Theory 2 on the topic, or you can say on the digraphs, is kinds of subdigraphs. So the topic is kinds of subdigraphs. So in case of undirected graphs, we have studied subgraphs, subgraph, spanning subgraph, induced subgraph, like that different subgraphs we have studied. So here also we are going to study different kinds of subgraphs. Okay. Now, if I consider a graph D is the directed graph. If I say V comma A, D equal to V comma A, what it implies? D is a digraph with the vertex set V and the edge set A. Edge set you may say, or you may say arc set. Okay. Now we consider different kinds of subgraphs. What happens with these combinations? Okay. So first, consider D dash is a digraph with the vertex set W and the edge set B. Okay. So we are considering with a different vertex set and edge set. What is W and B? We will see. So the D dash is a digraph which is a subdigraph of the digraph D. D dash is a subdigraph of the digraph D if W is a subset or equal to the vertex set V and B is the subset or equal to the set A. It implies you are considering few vertices of the vertex set V and few edges of the edge set A. Okay, so you may consider subset of V as well as the subset of A. Then the new graph is a digraph D dash with the vertex set W and B is called a subdigraph of the graph D. Very simple idea. There also we have considered a graph G with the vertex set V and edge set E. Then if B is subset of, or you can say if W is the subset of the vertex set V and B is the subset of the edge set E, there also you can say subgraph. Okay, subgraph, the vertices and edges of the subgraph are from the graph G itself. There, here also we have considered a digraph, subdigraph whose vertex set and edge set are the vertices and edges of the digraph D. Okay, so this is one subdigraph. Another digraph we are going to consider induced subgraph. So there what we did, let me recall. There, suppose G is a graph with vertex set and edge set E, vertex set V and edge set E. There we have considered S is the subset of V. Then the induced subgraph with the set S contains the how many vertices? The number of vertices will be equal to as that of the number of elements in S. Okay, but in the induced subgraph, two vertices were adjacent in the case of undirected graph if it is a maximal subgraph containing the vertices of S in G. Okay, so I don't want to confuse you. So similarly here also we have got induced subdigraph. Okay, here a subdigraph D dash with the vertex set W and the edge set B of the digraph D is an induced subdigraph of D if again the W, the vertex set, is a subset or equal to the vertex set of the graph D, digraph D, and B is B, the edge set of D dash is A intersection W cross W. That is very important. Okay, A intersection W cross W. So the idea of set theory is very useful here. So A intersection, the elements which are common between, the edges which are common between the intersection of W and W, that is one set you have to consider. First you have to find out W cross W. Then that is W cross W, what it implies. If W is having elements with 1, 2, 3, then 1, 1, 2, 2, 3, 3, 1, 2, 2, like that. Okay, so you first have to find out W cross W. Then you have to find out the intersection of A and W cross W. So the common elements between A and W cross W, that will be the edge set of B. Okay, so again it will be a subdigraph of D. So thus two vertices. In general, if I want to say graph theoretic way, it is in terms of set theory what I have expressed right now. But in terms of graph theoretic way, if I say two vertices u comma v belongs to w, two vertices u comma v belongs to w form an arc in d dash if and only if they form an arc in d. Very interesting. If you consider two elements u comma v belongs to w, so those two vertices make an arc uv, joining from u to v or v to u, form an arc in d dash if and only if they form an arc in d. Okay, so this is also another subgraph, and such a subgraph is called an induced subgraph. Let me consider another subdigraph. Here we used to say we won't say subgraph, we will say subdigraph because we are discussing digraphs. So another example, or you can say another case of subdigraph. What would be the another case? Suppose S is a subset of the vertex set V. Subset or equal to the vertex set. Every subset, every set is a subset to itself, like that. S is a subset or equal to V. Then D minus S, that is the digraph D minus S, is that subdigraph of D whose vertex set is V minus S. It implies from the vertices of the digraph D, you have to delete the elements of S. Okay, so that will be the vertex set of V minus D minus S. And arc set is A intersection, that is very important, A intersection of V minus S cross V minus S. See, V minus S is one set, subset of V. So that subset you have to consider, and you have to find out the product, that is what you can say V minus S cross V minus S. So that will be another set. Then after considering that set, you have to find out A intersection this the new set V minus S cross V minus S. The common elements you have to consider. Okay, so that will be the edge set of D minus S. Okay, so what I am going to say is that the set theory plays very important role here. How to find out V minus S. Okay, then how to find out the elements of V minus S cross V minus S. Okay, like that A cross B. If A is one set, B is another set, and then how to find out A cross B. Okay, so that idea is required here. So thus D minus S is obtained from D. Graph theoretic way, if I say D minus S is obtained from the digraph D by deleting all the vertices in S. Very simple. So you have to delete all the vertices in S. So whatever the elements are there in S, that you have to delete. Okay, that will be the vertex set of the new digraph D minus S. And all the arcs which have at least one vertex in S. That is very interesting. And all the arcs which have at least one vertex in S. If you simplify the set theoretic ideas, so you will get the arcs which have at least one vertex in S. Arc is nothing but it is an ordered pair. Ordered pair. So in that ordered pair, one vertex must be in S. Okay, so this is another digraph which is called D minus S subdigraph. Okay, then how to denote D minus V? D minus V means deleting one vertex from the digraph D. So that graph will be denoted by just D minus V. Okay, so another subdigraph is there, which is, suppose B is subset or equal to A. This is where A is the vertex set of the digraph D. Okay, then D minus B, similar to D minus S, D minus B, is the subdigraph of D whose vertex set is V. Okay, whose vertex set is V, and arc set is A minus B. See the difference. Here B is subset or equal to A. Then D minus B is the subdigraph of D whose vertex set is A. It implies all vertices will be same as that of the digraph D, but arc set is A minus B. Okay, so such a digraph is another subdigraph of the graph D. Okay, so similarly, how to denote D minus E? You may denote D minus E means deleting one arc from the digraph D. So you may denote this by D minus E. Okay, so these are the different digraphs, or you can say subdigraphs of the digraph D. Okay, so there will be slight difference between the undirected graphs and directed graphs. Okay, so in this session, what we have discussed what is the definition of a subdigraph, that is the vertices and edges of that digraph will be from the graph D. Okay, so then we have discussed about the induced subgraph. Then we have discussed about D minus S subgraph and D minus B subdigraph. So these are the different types of subdigraphs. So once again, you just go through the concept of the ideas of set theory, how to find A plus B, A minus B, what is the A intersection of two sets, what is the union of two sets, how to find the product or you can say the multiplication of two sets. So like that, if you go through the basic ideas of set theory, you will find out the elements. So with the help of those elements, you can form a digraph. Okay, so you will get different types of digraphs. Okay, I hope you have followed. Again, so these are the books for your reference. So with this, we conclude today's session. I hope you have followed what we have discussed in the session. Thank you.